Good evening and Happy New Year to everyone. My name is Rashmita and I'm the event planner at Microsoft Reactor Bengaluru, India. The session will run over the next 60 minutes, including Q&A. The chat will be open throughout and we do encourage you all to participate. Before we start today's session, please take a moment to read our code of conduct. We are all here to learn, so please be respectful, mindful, be friendly, and be patient to each other. I will share the Learn module link in some time. Please take a look. This one is quite interesting as both our speakers have handpicked the modules only for this session. I would now like to welcome Nish and Vivek, our speaker for today's session. Nish is a program manager on the .NET community team at Microsoft. Our next speaker, Vivek, is a senior cloud advocate at Microsoft. But for now, I will hand over to Vivek to begin the session. Over to you, Vivek.
Hey, thanks, Rashmita. Hey, Nish, how are you?
Hey, Vivek, very well. How are you?
Doing good. And for audience, Happy New Year. And this is our first show, and the first show of this year. And
This year,
Samosa and Chai is back this year as well. And Nish,
yeah.
knowledge check for you. How many episodes
Okay.
we have finished?
Oh my God. How many episodes did we finish? Maybe three, four? Four, maybe? How
Four.
many? Yeah, how many
Yeah,
did we
four, I
finish?
think so. No,
Okay.
I'm not keeping the count, as they say, right? So we don't need to keep the count. So, how was
Yeah,
your
Rashmita should
vacation?
be knowing it. Rashmita should be knowing it. Like, she should be
Yeah,
very
It's
familiar.
4.
Yeah,
it's
there you
four.
go. Yeah, it's four. So fantastic. So, yeah,
Cool.
it is. It's been, my vacation has been lovely. So, had a marriage in the family. So, very, very small affair, but at the same time, it was really fun as well. Yeah, I hope everyone is staying safe. And yeah, how about you, Vivek? What
Perfect.
did you do?
I took off to a beach
Oh
and spent
wow.
some time in the beach. And yeah, it's
Nice.
one more interesting thing happened there at the resort where I was staying.
Hmm.
I ordered for samosas, and
Okay.
the beauty is I got these small samosas, 8 samosas in the small samosas in the plate.
Okay.
So it's a quite a different one, not the one
Interesting.
usual big samosas.
Wasn't
Perfect.
that the regular, the potato ones, or
The potato
was it different?
ones, it was regular
Okay.
potato ones, but the small ones. But it was
Okay.
quantity was like 8, so it was
Yeah.
good. I
Yeah.
enjoyed it. So I enjoyed
Nice.
food. That's what I wanted to say. Okay.
Nice.
So okay.
Nice.
So what we have, Nish, today. So yeah, so we are going to talk about microservices and tools
Yeah.
uh, and tools which are required to build microservices and with all .NET is the perspective with .NET, right?
Yeah, so we've been I think we've been doing a lot of .NET related ones. Like since you have been completely new to the .NET, we've been trying and helping you understand .NET in terms of we talked about Blazor, we talked about Maui, we sort of talked about getting started with .NET. We also did some recaps on .NET 6, at the .NET Conf. So now let's shift our focus towards microservices, cloud native apps, and some toolings around there like the Dockers and probably the next session. I'm sure Vivek, who is an expert on the Kubernetes side of things, who will be taking care of the Kubernetes demos and things like that. But for now, we will just focus on building a microservices endpoint in .NET. So and then go into the details of how do you add or how do you containerize your application using Docker, and we can go into in depth into understanding how these things work as well, right?
See,
So
I told you
mhm,
I will get there. I'll get there with .NET
yeah,
demos and other things. So I'm here.
yeah.
So next session, I'll be doing the
Hey,
demo on .NET.
that's fantastic. See, that's I'm so happy to hear that. I'm happy that you're enjoying it as well. Not just we're just not doing the show, but also you're also learning. And congratulations to everyone who finished the Cloud Skill Challenge earlier. It was nice to see the leaderboard pop up and a lot of people completing it. Right, so it's fun. All right. So, so Vivek, let's talk about what are we going to learn today, right? So what we're going to do is we are going to learn what microservices are. So we'll talk about what exactly is microservices, why is it so popular nowadays, and then we'll talk about the technologies that are involved in helping you build microservices today, including the cloud native technologies like Docker. And then we'll also start building a hands-on demo of building a microservice endpoint in .NET. So let's get started. So to start with, what are microservices? Microservices are also known as the microservices architecture. Is nothing but which states that an application is composed of multiple smaller services that focuses on a specific business functionality. So it is not about taking a large application, spreading down into multiple, REST endpoints and projects, but it also is to understand okay, what is the business domain, identifying the business boundary, and then creating the services that are independent and loosely coupled, that it can work with other services. And the biggest advantages of microservices is that you can independently scale those services when in demand and things like that, or scale down as well, right? So yeah, a couple of things like that. And to speak more about it, we'll go into understanding of what exactly is a microservices architecture. Basically, there are a few things, there were a few characteristics that constitute a microservice architecture. So not every project that you start building today needs to be on microservices. Even though we're going to touch upon Dockers and Kubernetes in this session, it is not about microservices are not about just Docker and Kubernetes, because you can totally have a monolithic application and use Docker for that matter, right? Or you can use microservices without Docker and without Kubernetes and things like that too. So microservices are nothing but an architectural pattern which kind of helps people build services that are really small, they're independent, and then they're loosely coupled. So Vivek, what else can we speak about microservices architecture?
Yeah, so let me share a story. Okay,
Mhm.
so when I was heading the I was heading the DevOps in one of the startups. It was a 6 months, 8 months old startup when I joined in. So you know how DevOps will be, right? So
Yep.
it was just starting up, and we had three environments basically. One was dev, and pre-production, and then production environment. And one day, what happened was, and note that that startup had monolithic architecture pattern. Okay, so we were pushing code, and we pushed the code to pre-production, and we were supposed to update couple of packages there. We updated the packages, and we pushed it to pre-production, and it failed. And so we
Mhm.
went back to developers and said, hey, there is some issue, and let's fix it and other things. And a day goes by, we didn't push it to production, and we just go to the production and push the code without updating the package, because we had updated the package in the pre-production, so we don't have to do it again. So when we fixed the code, we took the monolithic application to pre-production. It worked fine because packages was already there. So we just have to pick that up, and we pushed the package to build to the production. When all this thing happened, the production goes down, and you know what happens when a monolithic application goes down. Your complete application goes down, right?
Yeah.
So for example, if I had I mean if that code base was for a pizza shop, which we have as a part of the learn module as well, right? So the pizza shop will have all of these catalogs and inventories, order systems, other things. So if it was a monolithic application, it would be a completely big application which will be deployed to the production. So to break it down into smaller chunks, breaking it to a smaller web services, so that people can access these services. Any changes made to these services will not affect the other services. So separating the code base is so, it's very important.
Right.
So that's what it is all about, having a separate code base for each of these services and making sure that they don't affect each other. That's one of the triad of microservice.
Yeah. So one quick thing over here is, even though we talk about separating code bases, I mean, there in the industry there are talks about having a mono repo for easier maintenance and things like that. I think it makes sense that too. But the important aspect to remember is, your CI/CD pipeline to be, independent of the each and every service. So that way, as Vivek rightly said, you when you have services deployment, you're not actually breaking the other services, thereby bringing down the entire app. So that independence is key. And also, I think another thing is, like, because the CI/CD is different, it also brings in that culture within the organization that every single service has to be looked at like a independent application itself. So that way, it's managed by smaller teams. It is managed by totally different teams. So that way, you can actually you fix a bug or ship a feature to the production without really worrying about it. You can deploy on a Friday, or you can deploy multiple times a day, because you know that there are ways you can roll back and update and things like that too, right?
Yeah, Friday. Don't touch Fridays. Don't touch Fridays.
Yeah. So yeah, so bringing up the next point, which is microservices are deployed independently. And this is something which I already mentioned, that you can redeploy it, and it gives you that much of ease, in which even if you deploy on a Friday, you will not be worried too much, because yeah, you will have nearly good amount of tool sets to kind of play with it, and if something goes wrong, you know what to do. They're smaller services, so you can roll back quickly, you can look into the issues quickly, you can ship another update quickly, so you can do a lot more things like that. Yeah. So what about data, Vivek? Like, I think one challenge that we always, I think every time we do this session, we also get this question is that, okay, so one of the independence, it comes from having the database separated, right? Because if you have a common database, then I think you're still bottlenecking into that data. So that means the databases have to be separate as well, right?
Yes, so it's very important to have its own state, right? So each and every services to maintain its own state, so that any update to these data, or if there is any upgrade is happening, there is no issue for the other service which is running. So the other service is not bothered; it is still running, and you're still able to order pizzas, right? If
Mhm.
review service is not running, you're still able to order pizzas, right? So that's what we want. So
Yeah.
that's the main reason why having a separate database is a good
Yeah.
architecture pattern here.
Yeah, I know that we are talking about pizzas a lot, and you will know why in couple of minutes. Is because the demo that we're going to show is on pizzas. Ideally, the demo should have been about samosas and chais, maybe. Maybe we can fix that for the next one or something. um, all right. So once you have the databases separated, then how does the microservice work with each other? And that's an important aspect, because um, uh, you know so the important thing to know is microservices interact with each other on a well-defined APIs or an endpoint, right? So you do not directly access, so service A do not access the data of the service B, which was totally possible in terms of, if you had a monolithic application, you probably had a one databases, and you'll have relational tables and things like that. You probably can have a store procedure there, pick up data from multiple columns and tables, and then pull the data in. But that's not allowed anymore, because that independence, if you want that independence of deployment, then you need to have those databases also separate. So in such a case is, the microservices do not directly access each other's database. Instead, it'll query the service itself. So how does it do? There are two ways you can do it. One is a synchronous way, which is like you can make an endpoint call. Service A can, for example, if you're in the ordering system, order system can make a call to the payment and say, like, hey, here's the order that is waiting for the payment, and then the process shifts to the payments, and payments can complete the order. Or the other way around is having an asynchronous communications, or something more like an event-driven programming style, right? So where you generate an event saying the order has initiated and now payment pending, and the payment system can actually look at this event and then start kicking in when that event comes in, and then process the payment, and then finally provide another status, which is has the payment completed or payment declined, and then the next available system will know what exactly to do. So that's how you kind of like split those the functionalities across all the services, right? And which comes up, which also brings up to an interesting discussion of supporting polyglot programming. What do you have to say about that, Vivek?
Yep. So one of the advantage of microservice architecture is that you can have these services in different tech stack. You can
Mhm.
with libraries and different frameworks, even different databases. In fact, so say for example, if you have a catalog service, you can have it with SQL Server, and you have a order tracking system, which
Mhm.
can be a having a MongoDB, or you can build something with .NET and then with Python, if you have some use cases specifically for those particular languages. So that is the advantage. I know as a developer as well, I was talking to you about this as well, Nish. So it's fun, right? So in the same company, in the same application, yeah, as a developer, I'm working on one of the tech stack, and if I have interest to learn something else, I can go to the other
Mm.
tech stack, but it is all difficult to manage, that. So
Right.
it's having one programming, having a strategy for one programming language is good. That is a way to go. And the use case of polyglot is as well, is if you are migrating from enterprise application to microservice, like a monolithic application to microservices, you have new services coming up. So those services you are writing in latest technologies, and maybe the older code base which you have might be still be running on PHP, and the new ones you're writing in .NET. So you still want to make sure that these are services deployed and working, and you're able to use it and slowly migrate from PHP to .NET. So that's how
Yeah.
you can use polyglot programming.
Yeah, I think the interesting point there is to even though we say microservices support polyglot programming, it's going to be more challenging if we start implementing more like a polyglot scenario. Even though that's in like if you have separate teams and you're able to manage, it's all great. But there are situations where you probably want to use common libraries and things like that. Then having a polyglot programming may be harder to do because sometimes maybe you're implementing a resiliency library to implement resiliency or something like that. Then you may be using one on .NET, and then you'll have to also find those similar things on other languages, and then support the similar strategies there as well. Although, I mean, resiliency is one example that I gave, but there could be many other scenarios, like maybe for authorization or something like that. Resiliency can even now, I think resiliency can be even supported on in using service mesh and things like that too. But authorizations or something like that, which makes it even harder. But the ideal scenario, as Vivek pointed out, is a scenario where you have legacy systems in place and you want to write wrappers around it, and then build microservices from there on. Then this makes it super easy to do. All right. So we have a question from Arvin. So should we take that up right now, Vivek?
Yep. Let me bring that up.
Yeah. So the question is, in microservice architecture, if service need to retrieve database in another service, should um, why should it go through integration as still possible to query directly to DB across services? Yeah, so I think that's exactly what we said. Like you shouldn't be querying through the databases at all, because every database. So the way you have to look at microservices, microservices have a specific split on the business domain. So I talked about ordering and payments. So payment can completely store its data on, say, a MongoDB or NoSQL database, and ordering systems can be on SQLs with relational databases and things like that. And so you don't have to really have those kind of libraries support on querying different ones. It is unnecessary. And also, you shouldn't be doing it because payment owns that whole thing. So the only gateway to the payments is through a well-defined APIs. So that way, let's say if you have to version it, like say V1 supports a certain level of payments. So when you come with V2, probably the V2 supports mobile payments. So all those interactions is better to do it at the API level. So that way, when the ordering is connecting to the payments, and if it needs to do the, let's say, mobile-based payments, it knows that it needs to connect through a V2 endpoint, and then it can work with it. So that way, the team and the service that is implementing that thing gets that complete autonomy on how they will have to implement that particular service, right? Have anything else to add, Vivek?
Oh, nothing. It's basically you have to talk through APIs, not directly
Right,
with database. So, yep.
right. That brings up an interesting question. So what scenarios you think we can use for developing microservice architecture?
Yeah. So there are a couple of scenarios. We can keep talking about on this slide. We're probably for half an hour, but I can talk about a few things, right? So, say for example, we are adding a new service. So there is a business problem you have, and you want to make sure you want to add that particular service into your application. And for that kind of a situation, right, if you're pretty agile, if you are divided your bigger application into a microservice application, then you have a smaller services already. So adding a new application, it's pretty easy to test, deploy, and manage it independently. Is pretty easy. So that is one of the scenarios you can use microservices there. And also deployment, we did talk about this, right? So you should be able to deploy independently the catalog service, the inventory service, the order management service. They are all deployed independently. They have their own code bases, they have their own version management systems. So you're pushing services to it, pushing code to it, and the services is getting updated, and it is not really interfering in other services. So other services is running, and there is no issue with that, because it is saving its state in another database, not the database of its database is also not shared. So that is the advantage of using microservice there. And it should be also scalable. Say for example, the the order system, right? You want to scale orders, the number of orders you're getting, you want to scale that specific service. So how do you do that? So that is where you can use infrastructure in terms of only to scale your specific service, if there is a lot of traffic coming in and you are scaling that. And it's also about how easy it is to build CICD for these services as well, right? So anything to add, Nish?
No, nothing much. I think you covered most of it, and let's go on to the next topics. I think we have some interesting questions that are coming up. So we'll take one or two right now, and then we'll keep going, and we'll take those rest of the questions a little later too, right? So one of the questions that came up, I don't get the user's name here. It says LinkedIn user. So as you said, if you go through event-driven approach to communicate to another service, and there's a follow-up question, which is how do we do the service discovery? It's a very interesting question. So so the way to look at it is like when you're doing more from an event-driven style, you don't do service discovery. Instead, you will raise an event, and you probably use something like a service bus, like RabbitMQ, or even the Azure Service Bus, where you will raise that event, and the service that is responsible for that particular for that particular event is going to listen to that and then process it, and further it will send back an event back to that service bus. So that way each other will communicate through asynchronous programming. So it's not through service discovery, but instead it's like you raise an event, and you have a standard way of communicating. That is probably it's a RabbitMQ or some sort of asynchronous communication system that you will establish there, right? Um,
I
cool.
think this is also a follow-up question for that, the same question. Yes.
Yeah, yeah. So yeah, you want to take that up? Good.
Yeah. So I think it's almost the same answer to that as well, right? So you are talking to different services via the APIs, and you're sharing information between each other, and that's how you maintain it. And again, as Nish mentioned, you will use an event-based system like the RabbitMQ and other things. So that's something we can use.
Yeah, and this question is about data redundancy. Data will be redundant across different DBs. That is correct. Data will be redundant, and right,
Redundant,
so
yes.
it should be as well. And the next question is like how is the redundancy maintained and verified? There are strategies for that that you can talk. We can talk about in length. I think this all things comes from a distributed computing model, right? Wherein you needed to have those systems in place which are distributed. There's no central way of looking at things. There was no central databases. So then there are things like cap theorem and things like that which come into play. We can
There,
go in
there are
length into
tools.
this. Tools
Yeah,
as well. Yes.
there are tools actually called as Debezium. It's an open source tool to make sure that anything you are updating data, it is tracking it in any of these microservices, and it is basically letting you know what's happening in the backend, and you can also verify data being updated. Once
Yeah.
you have updated in some database, that can send an information to the other database as well. So take a look at the tool Debezium. It's an interesting open source tool.
Yeah. Also, when we start doing the demo, I'll show you the ebooks that we write and maintain, where we have spoken about these things in length about data redundancy. Technically, it is not a redundancy, I would say, because if you follow the domain-driven design approach, you will follow something called as ubiquitous language, which is like you may say customer in a particular system. Let's say in an order system, you say customer, but if you're handling with a patient database or something like that, you probably will call it as a patient. So even though they are same people, they are represented differently in different services. So even the language that you use also can change, even though the data is going to be the same across. So there are like a lot of things like that which come into play. We will take more questions in a bit, but we'll just continue to talk about what we wanted to do today, which is about focus on creating the endpoint of microservices in .NET. Okay, so the next thing is what role do containers play? And I think containerization is an approach where you take your application, your configuration, your dependencies, including the operating system dependencies, and package them into a single deployable unit. And but this kind of technology has been existing for over a decade now. But the popularity comes from obviously the Docker that we call it today, right? It's also a company and also an open source project. You want to talk about more about that, Vivek?
Yeah, so Docker is open source containerization platform. So basically, containers were there, and Docker popularized it, and it gives you it made it life easy for us to package the dependencies, the package our code, and create a static representation of our code base, and also run it on with an engine it provides, which is the Docker engine. And
Mhm.
you just take that up and take your build your image and run it on the engine, and you just share your package in one of the registry, and you have it there. So it provides a amazing platform where you can build and also deploy it and share it and manage the network, manage the storage, how these different packages you create, which is the code base. You create the static code base of your smaller app or smaller service, can interact with each other and other things. It provides a framework for you. So that's what Docker is all about.
Yeah, and I think the important aspect or important point that I needed to bring up here is Containerization is just a tooling support that exists, but that has nothing to do with microservices. Microservices is just an architectural pattern which talks about a lot more things than what we spoke about. Characteristics, obviously the basic ones, but there are a lot of things that will go in. Once you start building it, there are design choices and strategies that you need to take. But containerization, the advantage of containerization is because they are packaged. Your application dependencies, everything is packaged into a single deployable unit. It definitely gets you that benefit of shipping your service or the microservice into production, which is same as the service that you probably tested it in a QA system, or the developer developed in a local system, because you're packaging that into a deployable unit which cannot be altered, which are immutable in nature. Which brings up to the next thing, which we call it as image, right? So you take your code, your configurations, your operating system dependencies, and your code dependencies. They're all packaged into a single deployable unit, and that image is that particular unit is called the image, or the container image. And when this image runs on a probably so where the Docker host runs, or in orchestrators like Kubernetes, they're called containers. So containers are nothing but a running instance of an image, right? So it definitely gives you that benefit, and that's why more and more, because of the cloud and because you have that, high bandwidth of the cloud, make use of the resources there. So you get that benefit of deploying it, like geo replicating your services, and scaling up and scaling down. So all these things are much more easily doable using these techniques and technologies. And to give you a fair understanding on how this thing works, let's look at how this architecture looks like, right? So you have the client, host, and the registry. So registry is where generally you will store an image, and the image gets pulled from the registry using the Docker pull command, and then it runs on a system which runs the Docker host. And then when you want to scale those services, you basically scale those containers. So it's just a single piece of image that's brought in, and then it can be replicated or duplicated on the services when you want to scale up. And similarly, you can scale it down as well when you don't need that demand. So that advantage that you get helps the microservices to kind of like scale up independently, scale down, and replicate and things like that. And also the guarantee that you get having an image that you tested in QA is the something which is going to be deployed in production as well. Okay. So let's go into the next one, which is so how do you build a Docker image, Vivek? So what exactly is a Docker file we talk about?
Yeah, as you told about the images, which is the static representation of your app. Uh, but how do you build that static representation? You need to provide a set of instructions to Docker engine, that this is the instruction, this is the build path, this is how I want to package it, and you package it and run it. So this is nothing but text file with instructions, and it usually starts with a base image. And if you see the example out there, there is two examples. One, if you see that if it's starting from, and you can see that Microsoft.com, .NET SDK 6, and ASP.NET framework is available there as well, right? So all these is already published in the in the public repository, which is on the Docker Hub, right? So you can just pick that up and use it. And it is, and it's basically already pre-packaged, so you just have to use this package and then get started with it. So anyways, while you are doing the demo, you anyways go into in depth with all of these. So I just want to say that Dockerfile is just a set of instructions, and these are the instructions. These are simple instructions you're going to provide to create a static representation of your app. It's still a it's still a package, it is not running. So if it is if you run this image, that's when you call it as a container. So that's the difference between just a Docker image and the container, right? So that's what it is.
Yeah, in short, it's basically the instructions that you give it to a Docker tool to kind of go and build your image. So we can go and explain these things as we start doing it in code in a bit. Which brings up another interesting, question is why build microservices in .NET? I think the answer to that is like, if you're new to .NET, like Vivek, we built .NET Core from ground up, and it is built for cloud, right? So that you can scale applications in cloud. They're smaller footprint, and it is also high performant. So when you build high performing applications, that means you're paying lesser cost in your production environments or in the cloud environment. So you get those big advantages. And if you have seen our previous demos that I showed on the same Samosa Chai, where we showed about the Azure Container Apps, which is the most modern way of building applications using serverless container systems. Like, there is Kubernetes, but there is no Kubernetes. So it kind of like gives you that flexibility of running it in Kubernetes without having all those ceremony that you need to do it on Kubernetes. So say .NET has this kind of a support in most modern cloud native technologies as well, right? All right. So with that, let's go and query some knowledge check on this topic. Go ahead and type in your responses onto the chat. The question is, which of the following scenarios would be a candidate to become a microservice? A web API that returns a list of pizzas. B, a web API and a website that return and display a list of pizzas. GitHub Actions used to deploy a website, and D, a Docker image. So we're going to give you some few seconds here. Go ahead and type in your responses, A, B, C, or D. What should it be? So the question is, which of the following scenarios would be a candidate to become a microservices? So what do you think, Vivek?
So yeah, let's go through one by one, right?
Mhm.
So it's not a Docker image for sure. You can still have monolithic application. GitHub Actions
Yeah.
is more of deployment, not a tool to be a microservice candidate. And website, returning website with API, it's a good statement that somebody is confusing someone there. So a web API that returns a list of pizzas, maybe the right answer.
Mm-hmm. Yeah, that's right.
Okay.
So everybody who, I think most of them has responded with A. That is the right answer because we were looking at there are like interesting play of words here too. So when you pay attention to those things, you will get the idea. A Docker image is, as Vivek mentioned, is just simply an image that you can create using Docker. It could be any application. It doesn't have to be microservice as well. Actions, GitHub Actions, you need it probably, but it is not technically candidate. But yeah, the A is the right thing because that's the very basic minimum need that you need among these options. Something like a pizza, which needs to be returned back. So a service, which is probably an order system, or catalog system of pizzas, is going to return back a web API. A list of pizzas in a JSON format or any other format that you need it, right? Okay, so let's go with another interesting question, which is, what purpose does a Docker image have in a microservice architecture pattern? So is it a text file with instructions on how to build a microservice? Is it B, a Docker image is a static representation of a microservice, its configuration, and its dependencies? C, Docker images allow hosts to perform load balancing and routing. So, what do you think, Vivek?
It's a text file with instructions on how to build a microservice. No, it's
No, that's a Docker file, right?
microservice doesn't pick it. Yeah, it is. It should be a basically it's a static representation of microservice. I kept talking about it. So it's configuration and its dependencies. So B is the right answer. So,
Correct.
but yeah, Docker images allow hosts to perform load balancing, and routing is something is out of question there. So
Yeah,
that's
it's
the
not the
thing.
Docker images that allows the host to perform load balancing. That's
Yeah.
right. So the B is the right answer. So congratulations to everyone uh, who has answered B. I wish we could send you samosas and chais on the show, but unfortunately we don't have an option to do that. So yeah, virtual samosas and virtual chais to you on the show who
Yep.
has answered the right questions. Sorry, right answers to these questions. All right, we have one more question. Question 3. Why would a developer write a Docker file? Because he's asked to do so? No. Uh, it's A, to create the initialization routine for the Docker engine. B, to create a text file with instructions on how to build a Docker image. C, to create the code to run the microservice. So I think it
Let's
got to be,
confuse people now. Let's confuse people here.
I think the answers
I
are
think,
enoughly confusing, right?
yeah, I think people are answering already. Yeah, they're answering it correctly. No, I
All the
don't think so.
right answers. Yeah. They're
All
answering the
of
right
them are
one.
right answers.
Yes.
Yeah, perfect.
So
Yeah,
that,
B is the right answer. So
yes.
it is to create a text file. Yes.
Yes. All right. All right, lovely. So let's go ahead and write some code now. So we will build a Docker file and then containerize our .NET application. So let's go ahead and see that. Okay, so this is my terminal window, and what I'm going to do is I'm going to increase the font a little bit here. And so this is the microservice MS Learn that I'm actually executing. And for the link for this will be shared with you, right, Vivek? I think we're going to drop it into the comments, right? A little later. You're muted, by the way.
Right
So,
now, I'm dropping it.
okay, so you can actually follow this along if you want to. Otherwise, just watch what I'm going to do here, and then, but be sure to go and try this out later, because now that you've answered all these questions, you can actually easily answer these questions as well on the MS Learn site and on your badges and things like that. All right, so I'm going to go to this unit 3, which is where the where the instructions are on how to build Docker files and how do you create a microservices endpoint, right? So the first thing I need to do is I'm going to clone a code from the Microsoft Docs repository. So I'm just going to copy this instruction here, and make sure you have Git installed on your system, so that the git clone command works. So I'm just going to go and hit enter. So what it's going to do is it's going to go and clone this repo from the origin. So if I go and see what's on my directory, I just have this mslearn directory, right? So to make it easier, what I'm going to do is I'm going to open this in VS Code. So here you go. I'm going to make it larger. So this is technically not a microservices project, but it definitely has a very basic endpoint created called the backend, which is what we're going to containerize it. So there's also a front end, and the front end is nothing but a simple UI that is going to connect to the backend. So we have a backend and we have a front end. Typical scenarios, what we want to show you is how do you start writing your .NET APIs and then containerize it, right? So this is a .NET 6 based project. So if you go, let's run this, right? So let's see what exactly happens. So if I go to the controllers, so this is a pizza info controller. So it's nothing but a simple pizza controller, which actually going to give you this static data. So there's pizza name, ingredients, and all these things. And the get method gets called, and then this whole menu that is here is going to be returned to the user, right? So it's going to be a very straightforward one. So I'm going to let's go and run this, right? So how to run this? I'm going to navigate to the backend directory and use command .NET run. So what it's going to do is it's going to I just brought this code from the internet, so I need to make sure that I have .NET installed. So if you're new to .NET, be sure to check out the previous episodes where we covered about how to you get started in .NET. So now I'm just doing a .NET run. So I have this thing opened on 5901 port, and if I click this, let's hope, yeah, there you go. So it comes on this 5901 port, but because we don't have an endpoint, I can navigate directly to pizza info. So this is going to give me the the JSON data that we saw, or if you want to know, like, what other APIs do we have it here, you can also go to the Swagger endpoint here, right? With .NET 5 onward, the Swagger gets baked in, so you don't have to, like when you create a file new project, you already have a template which gives you this thing, right? So if I click on get, it's nothing but the same thing that we saw. So it's a pizza info endpoint, right? Now, the next thing that I want to do, as per the instructions, is that I want to containerize this application. So how do I go ahead and do that, right? So let's do that. We go to this thing. There are instructions on creating the Docker file. So as we just discussed on what a Docker file is. So it's an empty file right now. And you can also notice that the Docker file does not have any extensions. So there is nothing like a txt or anything of that sort. It's just a Docker file. So just remember that. And all that you need to do is copy these instructions. So I'm just going to click on copy here and paste it. There you go. So this is my first instruction for building the Docker image from the SDK. But I also need to go ahead and copy one more instruction, which is the runtime as well. Okay, let me just explain you what exactly is happening here, right? So I think Vivek already talked about this a little bit, but I'll go a little more in depth in understanding, in telling you what exactly this is doing. So this is a multi-stage Docker file. So that means the first command from instructions, whatever you see here, it basically is actually pulling the SDK image. So in Docker, what you do is you always base out of a base image. So that's where you will make sure that all your operating system dependencies and all those things are coming in. So by default, the .NET using this Docker file, it's going to run on Linux, and then it'll have all the SDKs and the libraries that is needed for you to run on Linux. Okay, so I have a question here. What is the purpose of the copy command? I will explain that to you as well. Just give me a minute to get there. So the next instruction is work directory src. So basically what we're doing here is we are actually creating a work directory src and then copying the csproj. The .NET projects have this csproj file which has those instructions to help your .NET command run. So we are copying that to the inside of the Docker container, and then running a .NET restore, and then copying all the rest of the files, whichever is there, back into the Docker container, and then using a publish command. So basically what it is doing is, even if you have not installed .NET in the system, if you have Docker, this code is going to run, because what it's going to do is it's going to copy all the source code inside the Docker container where it's building, and then compile it inside that. So that's where the .NET publish command does. Actually, the thing that you saw .NET run, instead of .NET run, it's doing a .NET publish, because it does packaging of all these applications, and we can also send in instruction that we are going to do a release, and then the output folder that we say is copy that entire whatever the publish command generates. That's nothing but binaries, and those are put into the app folder inside of the Docker container, right? So the next instruction that you see that is again a from statement. So as I told you, it's a multi-stage building. So here what we're doing is, now that we have copied the source code and we built that image right inside the Docker inside the Docker container, what we're doing here is we are actually saying, okay, for this instruction, I only need the runtime here. See this? And then I'm copying this, the thing that was the previous one was left, the app folder, whatever was copied. I'm taking that and creating a new image out of that. So the biggest advantage with multi-stage Docker file is, you can have a list of from commands with other dependencies. For example, you may want to even run some test for your code, right? So you can have some test instructions and all those things. And the final image, the final from command that you write, that's what matters, because what it does is the Docker will ignore rest of the things and then build out of that. So the advantage that I have here is that I can go ahead and build everything inside the Docker container, and then say, okay, pull all the binaries from the app folder, and then execute this when an entry point is created. That means when you do a Docker run, it basically runs .NET with the DLL that it already has. So this is a big advantage of having a multi-stage Docker file. So it just goes and runs everything here, right? Okay. I have some more questions, so let
Is
me answer quickly. Yeah, go ahead. So what about
no,
NuGet
no, there's one
dependencies?
more
See,
question.
yeah. So Jeevan, what happens with the .NET? This is, you see this .NET restore command. So this is going to build. It is going to pull all the NuGet packages and then put it into the folder where it is compiling. And then when you do .NET publish, it is going to reference that and then publish the final one, right? And yeah, so that's what .NET Restore does. Okay, if you were, I don't know if you're like me. When I saw this for the first time, I was just wondering, why are we doing this? Like, why are we doing a .NET Restore and then copying, and .NET Publish will also do the same thing. So it's the way the Docker works is it always, whenever each instruction that you see here, it creates a layer, and the next instruction will create another layer. So if the previous layer has no more changes, so that layer will not be rebuilt, right? So that way it is always layered approach. So that's why when you do a .NET restore and then do .NET publish, you can still go ahead and make changes to the code. And as long as you don't have new NuGet packages added, that layer is not built again. So that way you can reuse that layer, and it caches. So your Docker build process is going to be much more faster. And that is the reason. This is just a simple optimization that we are doing to improve the Docker build time. But otherwise, you can simply have from .NET published directly, and it's just going to work. But the problem with that is, like, every time you change the source code, it is going to do a restore also. It is going to create this layer again. So that is the reason why we're optimizing this, right? So so that's what it does. So what we're going to do is we're going to build this. Now that we have the instructions for Docker to build this image, I can go ahead and build this. So let me just move this around and then copy the command. Basically, it is Docker build and tagging it. By the way, if you are if you're someone who don't want to copy these things and don't want to remember all of these things, make sure you install Docker extension either in VS or in VS Code. And in Visual Studio, you basically use a container tools additional thing that you need to install when you install Visual Studio. Once you do that, you also have a baked-in support for creating this file. So if you do a Control-Shift-P or Command-Shift-P in Mac, you get this option called Add Docker Files to Workspace. You click on this. You say what is that you're building. I'm building an ASP.NET Core application, and then which project it obviously detects two projects. So I can say I'm actually working on backend CS project, and then I can choose the operating system. So this is the operating system of your image. So you are basing it out of a Linux. And then once I put this and then put the port, it is going to generate this file for me. Now I'm going to cancel it because I already did that. So you can go ahead and use that extension to do that for you. So that, if you look at that, that also does this same optimization techniques to give you a faster build, right? So let's go ahead and build this now that I have this. So so instead of .NET run, I'm using Docker build, and you see that I'm tagging it also. So basically, the image that I want, the final image that I want to call, is the pizza backend. That's the name of the image, and then it's basically the dot is basically context where exactly is the Docker file. So right now, as long as I'm inside the backend folder. So right now I'm inside the backend folder, so it totally should be good. So I just hit enter, and you can see that you can see the layering that it is doing, right? Each instruction is basically creating a layer, and it is basically whatever instructions that you gave, it is doing that. And you can see that it is now saying cached. So because these are layers are being cached. So next time when you go and change some source code and build it, it is going to be faster because it'll use the cache to the point where nothing has been changed. So if you do a .NET, if you add a NuGet package, for example, that means the CS project was changed. So that layer has to be rebuilt. So it'll go ahead and build that layer for you, and that will delay as well, right? So this is the optimization technique that we use, and you can do various things, like you can run some tests like unit tests and things like that, and then basically the final image that you want to build, you can say, okay, if these unit tests, all those things passes, that's when you want to build the final images. So that way you can, when you do a Docker build command, a lot of things are actually encapsulated into that whole Docker file instructions. So that way, when you're shipping it, that it has the app has passed through a good QA, and then you can ship it as well. Okay, I saw some question, but I think I'll take that a little later. All right, so now if I just go and say Docker images, you can see that I have a lot of images. I work with Docker day in and day out, so I have a lot of images. So you can see that there's pizza backend, and it was built. Okay, so it says built 2 days back because we did this demo just 2 days back, and it's basically taking up from there, right? If I want to make these changes, I can basically do some changes over here, and then and make it build from scratch. Okay, I don't need to do that now because it's the same source code, so nothing has changed. And for those of you who are new to Docker, there are a few things I probably want to tell you is, like this is the Docker desktop that you need to install, and you probably want to, let's see, if you're using on Windows, you probably want to use this. Use the WSL2 based engine, because that way it becomes much easier to maintain, and you don't have to specify how many RAMs and how many CPUs that you want to provide while creating this Docker. So that's an interesting thing that you can do. And also, if you want to run these things, you can cancel this thing, and you can go and you can see that these are the images that is there here, and I can go and run these images separately if I want to from here. For example, let's say if I have to search pizza, I can here. So this is the one. So I can do a run here and provide some name. So I've got this as pizza backend container. So localhost, and I also need an AT port. So that's a container port, so I need an AT. This is okay, 510 maybe, 500, just and run. And then you can see that this is running on the 5200 port. So now I can go into my browser and go to localhost 5200 and hit Swagger, and doesn't wait. So let's see what is the AT port running on. This is the logs. Let's run this again. What is the port that I put? So Docker PS. Okay, it's running on the AT itself. So if I just do a local host and Swagger, and you can see that I mapped it to the AT port, so it's running on AT itself, so I can get to that instructions. And the reason why the HTTPS did not work is because I did not configure that for having the certificates and things like that. So that's why it's not working. But you can also make that thing work as well, right? So now I can go back and stop this thing. And if you need a command line instructions, you can also use this, which is docker run interactive, and remove once when you finish running it. It's basically removing the container and also specifying the port. This is what exactly it did. So for port 80, I mapped it to a host port called 5200, and then I provided a name of the container, and then provided my image that I need to run, right? So then if I navigate to that port, it is going to show me what port that I give. Right, so that was easy. So we just created a .NET app. Basically, we didn't create, we cloned it from the internet, and then we containerized it, and then we ran it, right? It's really simple instructions. And let's go to the next set of unit, which is microservices orchestration, right? So we are technically not going to talk about the orchestrator on this particular session, but we will cover Kubernetes and the orchestrator in the next one. So be sure to join us on the next one, but we will briefly touch on what exactly is a microservices orchestrator. What do you say, Vivek?
Yes. So we have multiple containers, right? So we could in the microservice world, we have catalog service. The pizza shop which Nish showed. We have catalog service, inventory service, and order service. So all these services have its own its own container. Now these containers can talk to each other and can share can share storage at some point. And also you want to make sure that 10 to 15 containers, you want to bring it up as a unit when you're building an application, right? So you want to use a simple orchestrator for that. So for that we have something called as Docker Compose, right? So
yeah, I think it's not exactly an orchestrator, to be honest. It's just a tool that's going to help you run all these images together, right? Because if you look at when you're building in your dev environment, you probably may not have Kubernetes to run all your services. And in reality, you probably will have many different microservices that you'll be working with, and it'll be hard to kind of run it on the local. So you probably have a couple of services that you depend on, or you're the services that you depend on, or you want to just test those scenarios on those services. Then you can use a tool like Docker Compose to kind of like build and run them all together, right? So basically, what we do is we whatever instructions that you saw, we're giving like Docker run, interactive, and port, and all those things. You can now provide in another text file, which is also a YAML file, and it's called the Docker Compose file. And you can put all those instructions in the Docker Compose file. So here, if you see, I'm trying to run two services together, which is the backend and the front end. So you can see that services which has the front end and which also has the backend. And we also specify, okay, what is the name of the image that you want to provide? So there's a pizza front end, and then if you come down, you see also pizza backend, and we say, okay, which is the Docker file. So each of the service will need to have its own instructions as well to build. So that's the Docker file specifically provided separately, and then you also specify. Oops, sorry. We also specify the port. Can you remove that learn module link there? Yeah, thanks. So you see that ports there. So here 590-280. So the host and the container port, what we provided, so that can be provided in a text file, right? So there was an interesting question that came up in between, which I saw, and I thought like I'll park it for later. And that one was about.
I did answer a couple of them with some direction in terms of websites.
Okay, you did. Okay, great, cool. So here, what you see, one more thing is the environment file, because the service A, which is probably the front end, needs to connect to the backend to get this data, and it needs to know where is the port, where is it running on, and because it needs to know that, it needs to be injected into the configuration systems, right? So that is doable by using the environment variables, and you can see that backend URL there. That's where we are passing in HTTP colon backend, nothing but the name of the service here. So we're just passing that in. And once you do that, your .NET system is going to pick it up from the environment and then directly try to hit this port. And because it's running, because the Docker Compose also create a virtual network for all your services to work with each other, the services can be discovered by the name of the service itself. So, right. All right. So quick knowledge check again. So if you are still there, here are a couple of questions that you can answer. First one, what is one use case for an orchestrator? And the options are A, to scale out and manage complex distributed systems of microservices. B, to hold the Docker images in source control. C, to automate security penetration testing. I have no idea what that means. So,
so it's definitely not security and penetration testing, and it's let's confuse people, A and B. Which one?
yeah.
I'm sure it's not Docker image, to hold Docker images in source control as well, because it's an orchestrator. It's about packaging. It's about bringing up all of these services as a single unit.
Right.
So it's always about scaling out and managing complex distributed systems of microservice. So that's A.
That's absolutely right, Vivek. You win the first prize. And also everybody who answered A on the YouTube channel. Thank you so much. All right, another interesting question. Vivek, are you ready? Which language is in Docker Compose file written? I think it's pretty much C#, I guess, right? Everything should be C#. You're showing something. I don't know what's written there.
It's
What's
written YAML is the new code.
That's right. Yeah.
YAML
So,
is the new code. That's here.
yeah,
So
when
yeah.
the world was getting over with tabs versus spaces, here we go. We have YAML to rescue, right? So that's right, people. YAML is the right answer. That's the language that you'll be writing the Docker Compose for. All right, so that's last instructions on this. So let's go ahead and create the Docker Compose file. I need to go to the unit 5 here. What I need to do is I need to just copy this command and then go back to my VS Code and then go to the Docker Compose file, which is actually in the root directory. So don't forget that. They are in the root directory. Here we go. So you post them there, and then instead of using a Docker Compose, Docker build or Docker run, you basically go ahead, go to the root, and then do a Docker Compose, and use an up command directly. So because what it's going to do is it's going to build both the images, and it'll recreate the environments for you, right? So when I do that, one quick thing I want to show you here is that when I go to the front end and the startup.cs over here, you can see that, when I am in the .NET code, basically when I'm creating the HTTP client, which is a pizza client that the application is going to look to connect to. So I'm actually looking for this variable called backend URL. As long as that is populated, I'm going to get the address of it. So if you remember in the Docker Compose file, we did provide that information over here. So that means it is going to connect to the backend internally. And this is, if you try to do this on your host system, it is not going to work because these names are accessible only inside of it. But if you want to expose outside, then you need to use this port that you used to expose outside, right? So what is the port that I'm running the front end? It's the finance02. So if I go into localhost and finance02, and it doesn't work, and it's probably because I have an HTTPS there, and again, I don't know HTTPS, that's why it's not working, but you can make it work, right? So there you go. So you can see all the JSON data that we were getting until now as a simple directly to the API. It's basically having a web front end, not as beautiful as you would imagine it to be, but yeah, so developers writing UI, so you can imagine how it could be, right? So yeah, it just works. So we just want to show you how to do that, and yeah, that's about it. I think we covered pretty much all the demos out here on time, Vivek, right?
Yes, and I want the vanilla pizza. I don't know what it means. You have a vanilla pizza. I haven't
Yeah, do
had
you
it
want?
before.
Yeah, I don't know what that is either. Let's hope that it's a good one. All right, so I think that's all we had. I think we can take some questions now. If you have any more questions, I think we missed a few questions. We can take a look at it. Basically, what we wanted to cover in this module was to talk about microservices in general, because this is a very basic session where we're getting started, and talk about one of the tools that you can use, which is the containerizations and cloud native technologies like Docker. So we talked about that. How do you do that with .NET code? And then building the endpoint, right? So we did that. So let's take up some questions, right? Let's take up some questions. Yeah. So Devashish says, so Docker Compose file is one level up of individual Docker files in a solution. It need not be, it can be anywhere, but the reason why we did that way is because the Docker Compose file has a specific path. It talks about the Dockerfile, which is the backend project and the front end project. So we have it in the top level solution so that it can be accessed correctly. It can be anywhere, it doesn't matter, but as long as it knows how to build your Docker images, that's where you need a Docker file. So as long as it is reachable there, it should be fine. It doesn't matter where you want to put it there. Okay, so any other questions? How is it going to work when we have separate code bases or services? Very interesting, very good question. I think yes. So that is the time when it doesn't, it cannot work, and that's why when you talk about microservices, they are specific, smaller services defined by business boundaries. But within that business boundaries, you can have multiple services too, right? You may have an order background service, which is basically looking at certain systems, and you may have some other maybe machine learning services for looking at spam orders and things like that. You may have other things. So in that case, within that microservices, you can bring up services together. So that's when you probably can use Docker Compose. But so don't confuse yourself between microservices as a pattern versus the Docker as a tooling. Tooling is for building up any apps and services. So you may have multiple services. That's when you bring it up. But if you're building microservices, as you rightly guessed, you would not be working with multiple. You may not even have source code for other services at all, because that is managed by a different team altogether, right? So in that case, they will have to be hosting it at somewhere where the endpoints are accessible. So when you're running your application, those endpoints is what it needs to access, not run those services on that, right? So for example, in Kubernetes, you can run multiple services under different namespaces too. So that way you can have those services access outside of like QA versus the prod versus the dev, and you can create those things. So one of the interesting thing you can take a look at is something called a Kubernetes bridge. Bridge, I think it's called Bridge to Kubernetes. It's a nice,
Bridge to
interesting solution.
Kubernetes.
Bridge to Kubernetes, yeah. So where you can have a Kubernetes environment where all the services are running together, and then you can have your dev side of things deployed, and then it can work with other services when you're testing the integration side of things. Cool. What are the other questions, Vivek? Did we miss out any other questions? We can take that up.
So there is one question, but I'm not sure this is complete. What happens when a Docker image lost in the repository?
I don't know. Maybe you can send us a follow-up question on what exactly you mean by that, because uh, if you shouldn't be losing a Docker image like that. I mean, if you are using a container registry, that's where the container registry comes into picture. So Docker Hub is one of the container registries, which we'll look at in the next episode, where we will ask Vivek to execute that entire thing on Kubernetes. So where he will be hosting that on a Docker Hub. So you will in your enterprise scenarios where you probably want to have some secure code to be deployed, you may use private container registries, and one of the examples is the Azure Container Registry. So you will be hosting it there, and these container registries can host multiple images, and they have those backing up systems and things like that, where you do not lose such images like that. Cool. Any more questions? I think we missed out a few questions in the initially, right, about microservices, and there
No,
was like
I answered them.
you answered
While
most
you
of
were
it. Okay.
doing the demo, I answered them.
Okay, great, fantastic. All right, I think we just okay. There's a follow-up question from Lalit on: can container handle such scenarios if images is lost? No, there is no built-in mechanism to handle any such scenarios that you're asking, because um, I don't know. I'm not very sure if a container should handle it, because once you create an image, that image it's a responsibility of your organization, or the org which actually maintains that microservice, to figure out from the infrastructure point of view where you're going to host this, and create a proper backing up systems for it to remain. And there are no built-in mechanism there to help you with that. If you go with something like a managed container registries, like Azure Container Registries, then these things are baked into the offering itself. So you don't have to do much. But as long as you don't go delete it yourself, it should be fine.
And you can also build it again if you are managing it on GitHub. The code base is on GitHub. You can always build it again as well.
Yeah, and specifically when you're using something like a GitHub, one technique that we use is we used to build images against the GitHub's SHA hash. So every time you check in a code into the main branch, we take that SHA hash and then map it to an image tag. So that way you know that which to what point of repository that image was created, and you can go even so you have a one-on-one mapping of the source code and the image creation as well. So there's some good practices that you can take on DevOps side of things to maintain that synchronization. Alrighty.
Okay, I think we are almost done with all the questions. Oh, it was a nice session, Nish.
Fantastic. So we talked about microservices. It was a fun session for sure, and I think the next one we are going to do more onto the Kubernetes, and then we'll slowly go into slightly more intermediate courses, like using those health checks in microservices and Kubernetes. We will more than the microservice design, we would be focusing more on how do you implement it, the cloud technologies that is available to you, and how can you leverage those things and kind of like speed up your app development with microservices, right? So we can do all of those things.
Do you want to take one last question? There is
Yeah,
one
yeah,
last.
good. If we are working in microservices architecture, if I'm working on a service A, but how can I get other service running in my local? Do we have any tools? Should we need to mimic the other services endpoints? Um, yeah, so I think one of the things that we have seen people do is like having a dev environment setup which mimics the prod environment or the other environments, and then you use them. Those endpoints will be accessible to you, and then you use that accessible endpoints to run your applications. The other thing that we do specifically with the reference guides that we use, like eShop and containers is a reference sample, which uses a bunch of microservices. We still use everything in a mono repo, so that everything can be run locally like a Docker Compose app. But we have the CI/CD pipeline separated in GitHub Actions. So that way, if I check in a code of a order microservice, it's only the order microservices that gets uh, compiled and get pushed, but it doesn't affect the other one. So that way we're separated. But standard practice would be to have an environment that mimics the production, and then your services can access them through probably some sort of a virtual network when you deploy them and check, right? So that's how you, when you talk about hundreds and thousands of microservices, that's how you would generally work with.
So Nish, we do we have any sessions planned around this? Um, Coming up
Um,
sessions on GitHub Actions, pushing
GitHub
code,
Actions, yeah, GitHub
Microservices.
Actions we can, yes. We will try
Okay,
to
we
do
are doing
something
it.
on GitHub Actions for sure, yeah.
Yep. So keep
Okay.
watching the space. So we will be doing it.
Someone is asking on the recording. Yeah, so the same link that you're watching on YouTube right now, will you can actually rewatch it as well. So because that's the same place where it's all getting recorded. Um, yeah. So how do we authenticate our services and things? It's the usual authorization and authentication practices that you will pick it up in code. You can use the same thing. If you're using .NET, you can use Azure's AD services.
Evolved,
Uh, It's called, yeah.
evolved. Azure
What's the, it's called
Active
Microsoft
Directory
Identity
Service.
now, right? Yeah.
Yes,
Yeah,
yes.
Active Directory now it's called, yeah. So Microsoft
Microsoft
Identity.
Identity. Yeah.
You can also use Identity Server, which is an open source implementation. So you can use Identity Server. So you can use this anything. I mean, it doesn't matter. Like whatever platforms that you would generally use on regular services, you can use it on this one as well.
Just one last thing.
Yeah. I think we can take
Somebody's
questions because
asking
we are
me.
here for the samosas and chai. We have time. Uh, and if you are in a hurry to go, so thank you so much for joining. But you can come back here and check these questions that we have taken up. If you want to take a look at it later, that's also doable.
Yes, and by the way, someone was asking about the Learn module, and that's the Learn module link on the
Yeah.
screen. Okay.
So, so someone's asking on the, can we have any learning path for microservices? Yes, you can. You do have. So if you go to the first section, the first session, one of these labs, when you it'll also tell you that what path you are in. So if you click on that, you will get the list of entire path, which will cover API gateway, service meshes. So if we are going to do that in every session from now on. But if you are in a hurry, you can go ahead and execute that modules yourself too.
Execute it and come back here and ask questions.
Yeah, absolutely.
Okay, perfect. Cool. Thanks, Nish. Thanks, Nish, for this amazing session. Thank you.
Awesome. Awesome. Thank you, everyone. Thank you for
Thank
joining
you,
and enjoy
folks.
your samosas and
Have a nice
chais.
day. Bye bye.
Okay. Bye.